Hey everybody, this is Larry. This is day 4 of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today we have 3403, which is apparently a poem that we've done recently-ish. I say that because of the high number. I don't know if I remember it. We'll see if I do. Apparently I did it in January, so we'll see. There's people asking me whether like I prepare / cheat for these poems, and no, because I barely remember the poem yesterday. Yeah, no. I think something about candy is the one from yesterday, right? So, no, I don't remember from yesterday. I'm not going to remember this one. But anyway, let's take a look at today's poem. I didn't do that much today. I went to the Yankee game, and that's it. Didn't really do anything gym-wise. So, anyway, yeah, let's take a look. We have 3403. Find the lexicographically largest string from the box 1. You're given a string word and an integer num's friends. Alice is organizing a game for her num friends. There are multiple rounds in the game where each round word is split into num friends non-empty strings, okay, such that no previous round has exactly the same split. All the split words are put in a box. Find the lexicographically largest string after all the boxes are done. Okay, so you're only given one round, right? Oh no, multiple rounds. Honestly, I don't know what I'm reading. What does that mean? Multiple rounds where each round, but how many rounds? Okay, I mean, okay, you have this, you have two friends. Okay. Huh? This problem is like, am I having like a brain damage issue? I don't know what this problem is asking. And I don't know if they proofread this. I don't know. Alright, you have given a word, you have an integer, okay. You're organizing a game, okay. There are multiple rounds in the game where in each round, after all the rounds are finished, how do I tell what all the rounds are finished? Word is split into nums. I see. So you just keep going, you keep splitting. So then now maybe you split. So the first time you go, this is a very poorly written problem, I think. So you go first time you split into say DBCA, and then the second time you and then third round. They don't even use the language here. Why don't they just go like, okay, first round we did this, second round we did this, so forth, right? Just give us one actual example that shows that you actually read the problem you wrote. It is very confusing. Okay, so this is only split, okay? So then now what does this mean, right? Well, one thing to note is that lexicographically largest, right, is always going to have the longest number of, the most characters, right? Because without loss of generality, if you, like maybe, what's it called? I mean, it's greedy in a way, but also the, like basically if you give two strings, and they both have the same prefix, and you always want to take the longest one because that's just the definition of lexicographically largest. And as a result, that means that if you have two friends, that means that you remove one character somewhere. And then if you have 4 friends, that means that you remove 3 characters somewhere, right? Those are all equivalent things. And then that means that now we're trying to figure out, and these are split, so it's going to be a longest substring. So that means that, okay, let's say we have n is equal to length of the word, and then we have, let's shorten this to f because I'm lazy. F minus 1 splits. Oh, sorry, f splits. No, f minus 1 splits because, yeah. And the number of splits, and every time you split, you remove 1 character. So that means that you want a string that is n minus this number in length, right? And I guess that's it. We're trying to find the lexicographically largest number, or sorry, string that is of length L, right? So now we reduce it to that far, right? Is there like an impossible case? I guess you can always do it. You just stop when wait, is that right? No, I think I'm a little bit off. I mean, this is kind of true if n and f is small enough, or they're proportionally whatever. But the case where that's not true is if you have, like, say n is equal to 1,000 and then f is equal to 5, then now you're gonna chop off 4 every time, right? Yeah, and then you keep going. So actually your L is not this, it's repeatedly removing this. That means that this is going to be this mod this, right? Okay. Does this make it better? I mean, L is still too long for us to do a for loop, because what I am tempted to do is something like, you know, you have something like right? If I don't know, words up from I prefix to I plus L minus 1, or maybe plus 1. I plus L, actually, I think that's fine. Is greater than some best, then best is equal to words I plus 1, or L, sorry. So I want to write something like this, and maybe it's even fast enough, but it's not what we want, right? Oh, why is this? And the two friends, so you remove one character. That means that is going to be, length is going to be 0. Did I do this well? Wait. Maybe I misunderstood this. Okay, so you remove. I see. I think I misunderstood this. I think the way that I understood it the first time is correct, because you put the strings. You still have the words again. Okay, so it's something like this instead then, right? Because then now, yeah. Because you don't repeatedly do it to the DBC. Okay. So I think this is kind of right. The only thing is that, well, this is n squared, right? Because n is, well, just of n. Here the L can be up to n, which means that every time you do this if statement is O of n, making this n squared. Of course, this may still pass because string comparisons are pretty fast in Python. I am going to YOLO submit it because I'm just curious whether this ACs. Oh, maybe not. Maybe I just don't even understand this. Oh, 1 is 0, so n, right? Did I have it off by 1 here? L is going to, because f is 0, then n is going to be, L is going to be n. So isn't it just I plus L? Did I miss off by 1 here? I'm really bad at this. No, apparently not. If you have one friend, oh, I guess L is equal to 1 is the exception case, because if L is equal to 1, then you don't do anything. You don't split at all. And and because you don't split at all, yeah, okay. The reason why this doesn't work is because I thought that you could split, and as a result, I didn't check the I put my was L, so this should be actually n minus L, and I think that's fine, right? Or is it n minus L plus 1? Yeah. Still don't think it's fast enough, but I just want to YOLO submit it. Ooh. Man, maybe I don't understand this problem at all. Okay, so you have two friends. First split A, N, N. Why is ANN not the... Did I misunderstood this problem? I mean, clearly I am. Do I not know what lexicographically is? I mean, they give you the answer for lexicographically smallest, but even though this is largest, I am so confused about this problem. Oh, NN is lexicographically larger. Okay. Oh, I guess my greedy is wrong. I guess that's it. Huh. I see, I see. My greedy is wrong. So I did say one thing about greedy of lexicographically largest, so that it will always have length L, what this length is, but I'm wrong here, right? No, I'm wrong here because I go out bounds here. So maybe I am, so this is more right, I suppose, actually. Yeah, this is more right because I chop off. The only thing is that I guess L is equals to 1 is the weird case, because if L is equal to 1, then you can't cut, so you just return word. Is that good enough? Honestly, I feel like this is a very poor showing, but huh. Did this not work before? I don't get it. Oh. Well, this is L is equal to 0. I messed up, that's why. I was so confused. Okay. Because F is equal to 1, not L. But in any case, it's still wrong. But this is if F is equal to 0, not L. Oh, it's F equal to 1. What am I doing? Sorry, friends. I'm like way... I don't know. I'm looking, and I'm not even distracted, but... Alright. Just a couple of silly mistakes. But this is still n squared, though, so we should do a little bit better than that. How do we do better than that? Because this is, even though it's hidden, it is still n squared, like I said, because this is, or n times L at the very least, which maybe is fast enough, but it's still, you know, if this is 5,000, 5,000 square is 25 mil. Maybe 25 mil is roughly not, maybe it's barely fast enough. That's still very awkward, honestly. What did I do last time? I made the same mistake. And I made the same mistake again. I try to fix it the same way. That's funny that I did. So, okay. So, if nothing else, I'm consistent. So, if you could say that I prepare for this, I literally prepare by doing the wrong thing literally twice in a row. That's kind of hilarious. But, can I do faster than n squared or n times L? I mean, you can move a suffix away and then just walk the DAG, right? Walk the DAG of at most length L. I guess that's it, right? Do I have a suffix array library? Let's see. Yeah. So this is going to be good enough for n times L, but I think the canonical way is just having suffix array, and then find the lexicographically largest string that is at most length L. That's basically the thing. So you definitely need a suffix array. And apparently, I'm just going to use this thing from ChatGPT since I can't find mine, and then see if it works. Right. Okay, so what does this mean, right? I guess that's just the suffix that comes in last, right? Because now we have a suffix array, and I could print it out real quick, right? So print, what's it called? Build. And this is extra credit, by the way. If you know, it's probably fine if you're not familiar with this. But this is 3210, okay. But we want to do it such that it is length L. I guess this should be good, right? Because here, I guess we can also do that one, right? That means that we want. Oh no, yeah, we want the 3, right? So then now the first element is going to give you the prefix. Oh no, the last element. Sorry, the last element, right? So then now, because we want the lexicographically largest, right? So that means that, okay, let's say we build the suffix array, right? And I'm not gonna go over suffix array in this problem because suffix arrays are kind of ridiculous. I mean, you saw it. I don't really have code for it because I've only implemented it like maybe once or twice in my life. Well, that's not true. I implemented it more, but it's just that I didn't implement it efficiently, right? Because I've done suffix array and suffix tree before, but suffix array I did not do very often. And I used to do it with C++ or C, not even C++, because it's easier to do in C because then you could sort the string pointers by having a pointer on each one and do comparison that way. It's actually kind of ridiculous, and it gives you like log square n in a way short line, but I don't know. Right, so suffix is equal to this, and then now we just have to find the max element, right? And the max element is going to be, well, we have n elements, right? So the max element is going to be n minus 1, right? So suffix dot index of n minus 1, because literally that suffix array gives you the sorting order of maybe I didn't say that right. So basically suffix array sub I is going to give you gives you the suffix of I smallest array, right? String starting at that index. So that means that if suffix of I is equal to 5, then suffix of I, or then string starting at I is the fifth largest, or fifth smallest, smallest string, right? So that means that here, like I said, because we have n characters, we want n minus 1 is going to be the lexicographically largest. And then the only thing that we have to do is just reconstruct the string, right? So we have s is equal to this, and let's just say start index maybe, right? And then now we just go, answer for I in range of L. And the reason is because we still only want at most L, right? Answer that append word sub I plus start index, but only if, if I plus start index is less than n, right? And then that's it. Right, so everything looks good, and now this is n log n. Right, let's go a quick submit. Hopefully this is still right. Ooh. Did I cut off too much? Maybe I'm just wrong, to be honest. Maybe I made a mistake. But it's always good to learn. So let's see. What do we have here? We have to use what we have here is that we have to use the test case first. Huh. Did something mess up with this C? Did I mess up? That's not how the suffix array work, right? I mean, I'm using it as a black box. That's why I'm a little bit confused. But ideally, this should return that B is 0, C is 1, and then D is last, right? Am I doing it wrong? Let's take a look. I mean, if the black box is right, then it should be right. But I don't know why this is so weird. It's either that or ChatGPT failed us. Oh, I think I'm confused. Okay. I think we just got very lucky. Let me double check real quick. Yeah, I think this is supposed to be, yeah. So I interpreted the suffix array wrong. So that's why. So this is not the case. What this is that, no, this is right. No, you're right. Oh, wait, no. Wait, what? Sorry, give me a second, friends. I think I'm inverting something, like I'm mapping it incorrectly. Because 0. Oh, yeah, okay. I see. No, I was mapping it incorrectly. I was saying this, but this is wrong. What this is saying is that, so suffix sub I, I've forgotten how we use it, apparently. Though I think it just depends on how you set it up. But suffix sub I is equal to the I smallest string starts at index suffix of I. So basically, like I said, I inverted the definition. And maybe I just got a little bit unlucky or lucky, where the first 4 cases, both interpretation was ambiguous. So then now that means that start index is equal to suffix of -1, the last one, right? Because we want the biggest. That should be good. Yeah, okay. Yeah, so that's how you use suffix array. Apparently, I forgot. But I don't. Is that the standard definition, or am I just kind of. It's been a long time. It's been years. But yeah, if you're curious about suffix arrays, definitely check this out. Maybe it's needed for the harder version of this. I don't know. What does the hint ask you? Okay, well that's fine. Yeah. Anyway, that is all I have for this one. Let me know what you think. I did upsolve it a little bit today, so and clearly not prepared in ways good or bad. But yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.